Swayam Prabha. Digital India. Educated India.
Welcome back, and today we will start module 8. Module 8 is water carriage system, and in lecture 36 we will talk about water carriage system and sewerage layout. The different concepts that we will cover in this lecture are on water carriage system, types of water carriage system, combined system, separate system and partially separate system. These are different types of water carriage system. Then pressurized sewage system, vacuum sewage system and patterns of sewage collection system. So, in the last module or in the last set of lectures, we have talked about the different kind of sanitation systems, and then we have talked about decentralized systems, on-site systems, and we have also talked about water carriage systems. Or in this particular case, when we talk about a water carriage system, we are basically referring to the conventional sewerage system. So, in water carriage system, as the name implies, it actually means that water is utilized for carrying the sewage. So, as you know that water is the cheapest alternative and it's for collection and conveyance of sewage. So, we use water, and when we are doing using water, then and all the systems, the design that we are doing for the pipelines and all, we go with the assumption that the sewage that we are carrying is basically 99.9% water, and solid excreta is more or less just 0.1%. So, that basically means that we would be designing the system mostly considering that we would be carrying water throughout the system, even though we need to also understand that it is not exactly water. So, we need to do those considerations, but in general the idea is it is mostly water, and the system is designed thinking in terms that we will be carrying water throughout the system. So, solids remain suspended in sewage, and it does not change the specific gravity of water more or less. And as you know that this conventional sewerage system or water carriage system is much more costlier, and it is difficult to maintain as well. We have to spend a lot of money on operation maintenance, and during monsoons the amount of sewage that is generated, that is of quite a bit, and we have to actually consider that, because it is not only the sewage that is generated from our houses or from industries, but also the storm water that has to be considered. So, this high volume of sewage maybe becomes a problem during the monsoon period. So, we have to also devise ways to handle this kind of this volume of sewage. So, overall in general we can say that water carriage system is much more hygienic, because the sewage does not stay at the place of generation, it is immediately conveyed. Then sewage also is carried through closed sewer systems underground. So, this reduces the rate of epidemics, because people are not coming in contact with the sewage. Self-cleansing velocity is attained because of increased quantity of sewage, and land because we also use water and we have to put in adequate amount of water. And then the land required for disposal is less, because we are treating the sewage at sewage treatment plants, and then we are only releasing the effluent into the river, and only the sludge part has to be dealt with. Either we can take it to the landfill, and sometimes sludge could be even walked upon, and we can make it into manure and so on. So, in terms of the building, because we are using a water carriage system, buildings could be built as a single unit. That means the toilet does not need to be separate, it can be within the building, and water supply to building is adequate. We do not need to add extra water. So, because whatever water we are using in our flushing systems, that is adequate to carry the sewage. And because we are treating the sewage in sewage treatment plants, we have an opportunity to reuse parts of it, like we can reuse the effluent because we are already treating the sewage, so we can reuse the effluent for certain purposes, and no human agency is also involved in this particular system. So, what are the different kinds of water carriage system? There are three kinds, but of course, there are overlaps also. I will come to that. So, the first is of course, the combined system. So, this kind of sewerage system actually carries both the sanitary sewage as well as the storm water. So, all kinds of water that is generated in an urban area, either from a storm event or a rainfall event, or from the sewage that is generated from your houses, are all carried through one single pipeline. So, this is a combined system, and separate system is obviously just the opposite of that. That means domestic and industrial sewage, if that is there, is taken through one set of sewage, and stormwater, sewage and surface water in another network. So, stormwater, sewage and surface water is basically water which we can release to the river without much of any treatment. That is why it is taken separately, whereas the domestic and industrial sewage that we have to treat, and that is why it is taken separately. And in partially separate system, there are a lot of overlaps that I was talking about. Then portion of the stormwater is allowed to enter into the sewer carrying sewage, and the remaining amount flows in separate set of sewers. So, we have two set of pipelines. So, one set of pipeline is dedicated for stormwater, another set of pipeline is dedicated for sewage, but certain things like the storm water that is collected in our roofs, maybe within the layout of the building, within that particular plot, or maybe the sewage from the toilets could be actually going through is actually added to the sewer pipeline, whereas sewage pipeline, whereas the stormwater that is generated from the streets or from the surroundings or from parks and other places, that goes through the stormwater drainage network. Then again, there are different obviously variations to it, because in many Indian cities, people do not maintain two sets of pipeline in their houses. They have only one set of pipeline, that is sewage as well as sewage, everything goes out of the house through one set of pipeline, and definitely in that case, even though the authorities may not want it, but the pipeline that comes, the sewer pipeline that comes out of the house is actually a single pipeline, and that is connected to the sewage system. So, or the sewage pipeline, right. So, in that case, automatically it becomes a partially separate system. So, there is no exactly, we cannot say that these are the things that has to be added, but in most cases this is what we find. So, in general, sewage system is gravity based, but in addition to gravity based sewage system, we can have certain kind of pressurized systems, such as vacuum sewage system or a pressurized sewage system. So, in special cases, we usually use this kind of systems, particularly when we have to lift sewage, there is a lot of lifting involved. So, instead of having lifting stations, we can go for a pressurized sewage system, or sometimes when there is a small community, there are a lot of basements and all, we can go for a vacuum sewage system. This kind of systems could be also there. So, when we will go for combined system? So, combined system, as you understand, is a combination of all the sewage that is generated in an urban area, including stormwater. So, it is definitely suited for areas with less rainfall, because if we go for a separate system in this kind of areas, then what happens is we may end up with very little amount of water in either of the pipelines, or particularly in the sewer lines. So, it may result in lot of siltation and deposition. So, that to prevent that, it is better to have a combined piping system, combined pipe or a sewer system. So, it is usually in less rainfall areas we go for a combined system, and because we are going for a combined system, self cleansing velocity does not becomes an issue, it is always available, and again because it is a single pipeline, it is easy to lay, and house pumping, there is no other considerations, one pipe is adequate. And then but the thing is, because we are going for a higher diameter pipeline, we have to have a higher diameter trench, and usually and the entire system will also require a sewage treatment plant, which is going to handle a much more load compared to a separate system. So, overall we end up with much higher cost compared to a separate system. And then one problem is during heavy rainfalls, because as you can understand, huge quantum of stormwater is captured. So, we cannot treat this kind of the entire amount in our sewage treatment plant, because it would be uneconomical. Because the rest of the year it would not be able to treat so much quantity. So, we would be designing pumps and all, which would be of excess capacity, which is not utilized throughout the year. Only during 1 month or 2 months of rainy season it is utilized. So, better what we do is we do not design the system for that, and what we allow this excess storm water that is generated during the rainy season to just pass without treatment. So, because we are allowing it to pass without treatment, it is dangerous for human health. It may create some other environmental and other health problems. And during dry weather, some amount of siltation may still take place in this kind of pipelines, because the pipe diameter is bigger, and there is no storm water available during dry water. So, very little flow is there. So, some siltation can happen during dry weather. So, then comes the separate system, and obviously this is just the reverse in many ways. It is just the opposite of what we have talked about for the combined system. For example, it is suited for areas with heavy rainfall. So, obviously we separate the storm water, it goes and it is directly drained into the river. It does not affect the treatment units and all, but and also that means that we are able to, because it is a heavy rainfall, some amount of water in any case seeps into the sewage network. So, self cleansing and all this velocity in general is not available, but during dry weather it may be a problem. So, self cleansing velocity is sometimes not available during dry weather and all, and so we need to make arrangements for separate flushing system in the sewer lines. So, that means we install certain tanks in the sewer lines which acts as cisterns. That means that you find in your WCs, that when you flush it, then the sewage is carried out. Same way, we have a larger tank in the sewer network which could be used as a sort of cistern, and it can be used for flushing the entire sewer line. And the quantity of sewage is of course low. So, size of sewage treatment plant is much smaller, and then storm water is taken through different channels, and it could be even open channels. We may not even consider underground sewer pipelines. So, we may even save on constructing pipelines in that regard. And then there is of course, because in case we lay 2 sets of pipeline, then it may be a problem, and also cost is also high for 2 pipelines. Even though the pipeline sizes would be smaller, overall cost comes down to be probably a little lower, and maintenance is of course high, because 2 sets of pipelines has to be maintained, and pollution risk is less, and always it is better to have a separate system in that regard. And risk of stormwater entering sewer resulting in heavy load and breakdown of treatment plant, that is there, but usually it does not happen. If you have a properly defined 2 separate system, then this does not happen. So, this is a separate system, and in partially separate system, as we have discussed, it is suited for dry weather conditions, when there is no self cleansing velocity. So, that is why this extra storm water from roofs or maybe sullage can be added into the sewer pipelines. That actually helps in attaining that self cleansing velocity, and cost of pumping and treatment is usually more than the separate system, because we have to treat more quantity of waste. Then this is you can see the image of a pressurized sewer system. So, we have a building, or this is from the the plots, and then we have something called a sewage pump and vault, and then there is the pressurized sewer lateral, or lateral is basically referring to the sewer pipeline, right. And this is the road, below the road we will find, or below the footpath we will find the pressurized sewer lateral, right. So, it is just a pressurized pipeline. Instead of a gravity based flow, we are having a pressurized pipeline, right. So, in a pressurized sewer system, slope is of course not that much of a concern, because we are putting in some amount of pressure, we are generating certain pressure, and particularly this pipelines can be laid even over the ground, and of course they need to be anchored. So, that means in case we are not able to put in the pipelines below ground, so of course we have to have a pressurized sewer system. So, in some cases it is difficult to dig, like maybe in rocky areas and all these places. So, it is better to have a pipeline above ground, and then probably we have to go for a pressurized sewerage system. and smaller diameter pipes could be used because we are using pressure, and manholes are not required, and due to positive pressure chance of infiltration is less, leakage is detected easily. So, it is almost like a pressured conduits of like water supply pipelines. So, the design is more or less similar. As we know, the formula, we cannot use Manning's in this kind of pressurized pipeline. So, we have to use the other formulas which we use for water supply. Even we can use the similar kind of formulas for determining size of the pipelines and so on. So, one thing is usually what happens whenever we are trying to improve a particular sewerage network, or like a city used to have an old sewer network, like you can see that this is the old pipeline, and now we want to augment this pipeline or rehabilitate this sewer system. That means, in many cases we need to upgrade the sewer system. So, it is very difficult to again start constructing a totally new pipeline. For that we require extra space and so on. So, one way to go around this is use the existing pipeline and put another conduit in between that, and because as you can see that now the conduit would be smaller in size and all, this could be a pressure conduit. So, instead of using the old conduit, which is actually some issues, if there are certain issues with that, the blockages, chokages and all. So, we clean those things and then we put in a new line, as you can see in this one, which is actually this pipeline could be under pressure, and that because it is a smaller pipeline compared to the one that was earlier, and because it is under pressure, it should not be any problem. That means, the quantity that we can send should not make any we require a lesser diameter pipeline in that case. So, in that case, new pipes can be laid inside old pipes using trenchless technology, thus reducing disruptions in traffic and all the other issues that's there, because we cannot create a new pipeline, or we cannot construct a new pipeline because the roads may be congested, too much traffic, we cannot disrupt it. So, all these issues we can go for trenchless technology and rehabilitation of pipelines, and this is what is being done in many cities right now. I will show you other examples as well, and this is where pressurized systems could be utilized. So, what is the difference between a pressurized system and a normal system? That means, there is a pump involved, right? And what is the difference between a water supply system and a sewerage system, pressurized sewerage system? So, that means, because this is not pure water, it is sewage, there has to be something else. So, that is why we use something called a grinder pump. So, grinder pumps is used to pump waste from the residences to the low pressure sewer line. So, this is not a very high pressure line, it is a low pressure line, and grinder pumps grind up any solid before pumping. So, that is, so as you can see in this image, this is the grinder pump, and the grinder pump, actually one job of it is to not only pump the sewage, but also to grind the sewage into, if there are particles or larger particles in that, it would be made into very smaller particles, and then it is pumped into the network. So, actually in that case, it will not change the flow characteristics and all the other parameters for determining this flow, velocity and so on, right. So, that is why we need to grind the sewage and then send it up. So, usually in case of larger plots or commercial plots, in addition to this grinder pumps, before the grinder pumps, we should have these grease interceptors, so that oil does not get into the system, because if oil gets into the system, it will choke the pump eventually, and then it will stop operations. So, first oil is trapped, and after that we let the other sewage get inside, it gets grinded, and then it is sent via pressure. And this is, of course, you can understand, it is a costly system, there are pumps involved, there are other installations involved, so on, but it is required when we had no other option. And it can also pump sewages from basement, because we are creating certain amount of pressure. So, vacuum sewer system is another alternative to pressurized sewer systems, but of course, vacuum sewer systems operates in a different principle, and also the pressure that you can generate is limited in this vacuum sewer system, but for smaller networks and all, sometimes it becomes more efficient, right. And you can because it does not require individual houses to have these grinder pumps and all. So, it is better to it is a centralized system, where from centrally we can control this this sewage collection. So, in a vacuum sewage system, it collects sewage from different sources and conveys them to the sewage treatment plant, and for this we require a vacuum station in this particular network, and that vacuum station is actually generating that vacuum in the collection system, and this vacuum is generated in the capacity of that is lifted to around 9-meter head. That means it has capacity to lift water up to 9-meter level. So, not more than that. So, beyond that it is not achievable. So, what we do is the system is designed in such a way, so that we have, as you can see in this particular houses, there are these gray boxes. So, what are these gray boxes? This is basically a collection chamber, and from there from the collection chamber the sewage goes into the main lines, from where it is sucked into the vacuums via the vacuum station into the sewage treatment plant. Right. So, from that vacuum station is actually just creating the vacuum, and from here it actually goes into the sewage treatment plant. Now, what is this collection chamber? Collection chamber is in detail you can see over here. Now, collection chamber is basically it is a pneumatic pressure controlled vacuum valve in a valve pit, and it opens when a certain amount of sewage is gets filled inside this particular pit, and then this pressure controlled vacuum valve opens, and then the sewage is sucked into the system. So, the vacuum is always there, but this valve actually closes this pit. There is no continuous pressure on that particular system. That means that the building will not face any kind of suction over there at the WCs and other places. So, what is happening is, when a certain the sewage that comes out of the building is first stored in this particular pit, and when it gets filled to a certain level, then this valve opens, and then it makes sure that the pump is connected with this particular vacuum network, and then because the valve is now open, the vacuum actually is able to suck in the sewage from that particular pit into the system. So, that is how this entire system works. So, there is difference in pressure between the valve pit, which is at the atmospheric pressure, and the main vacuum line, which is under negative pressure, actually pulls the sewage and also air into the system. And the sewer lines are installed in a vertical zigzag configuration, which is different from standard sewer lines. So, as you can see over here, it is a vertical zigzag configuration. That means the sewer line goes like this. So, in this way it goes up. So, it is and then it is eventually connected to this particular vacuum station that is there in the system. So, the difference with the pressurized system is, over here also we require this collection chambers, but it could be installed from the municipal levels, and also it could be also installed from the building level, depends on what city or what are the rules in that particular area. And this vacuum station is a centralized system which actually creates the suction, whereas in the other one the grinder pumps and all has to be there in the building itself. So, that means it is a responsibility of the user. So, that is the basic difference between these particular two systems. Now, we come to now that we have covered the different broad kinds of systems that are there, now we should also look into the patterns of sewage collection system. I will tell at the beginning that these patterns, even though we would learn it as formal patterns, there are mainly 5 patterns of collection system, like perpendicular pattern, interceptor pattern, radial pattern, fan pattern and zone pattern. So, these are the 5 patterns, but usually when we look into a actual urban area, it is very difficult to say that this particular sewerage network is following this particular pattern, because a sewerage network depends on the city's layout, and it got and the options to dispose the waste in that particular city. So, many things play a role, but fundamentally we can understand that this more or less relates to this kind of pattern, or this is a mix of these 2 kinds of pattern. So, it could be a mix of certain patterns as well. So, what are this sewage collection system depends on? So, as I was talking about, it depends from area to area. This system varies. It is not only a single pattern, it could be a mix of different pattern, and particularly it depends on the topography of the area, and the hydrological features of the area. So, these are the primary two concerns. Then location and method of treatment plants, what kind of treatment method we are using. If we are not using, if we are using a sewage treatment plant which releases effluent into the river, then obviously we will have a certain kind of system, whereas if it is practicing sewage farming, then obviously we will have another kind of system or another kind of layout, actually not system. So, type of collection system and also area or the catchment area of the sewage. So, all these things play a role in determining what kind of system that we are going to lay. So, the first system is the perpendicular pattern. So, again when I am saying that perpendicular pattern, it may be along with many other patterns as well. Why? Because perpendicular pattern actually refers to the cases where sewer carrying storm water are laid in such a way, so that it seeks the shortest possible path to the water course. So, the city has got a river in front, like over here as you can see in this particular image, and we have an urban area over here. Whatever the size of the network is, it may not be even in a grid iron pattern over here, but it is laid whatever way the city is laid. From different zones, we have this direct stormwater pipes which are perpendicular mostly, and they directly fall down onto the river. What it means is, from that particular zone, whatever stormwater is collected goes into this main pipeline and stormwater pipeline, and directly the water is taken out to the river. So, why this is done? So, it's done so that we can easily get rid of the stormwater, where this would be done in cases where there is a lot of flooding and all. So, in that case, we want the flood water to be, or the rainwater to be out of the city as fast as possible. That is when we are going to design this kind of a system. So, perpendicular pattern is good for a separate system where stormwater is disposed without any treatment, and and this kind of large outlets are difficult for setting STPs, and we can release the water without treatment, or if we want to treat it, then we have to set up large STPs for this kind of system, and multiple ones as well. Then comes the interceptor pattern. So, this is better than the perpendicular pattern. Why? Because sewers are intercepted by a large sewer which carries sewage to a common point where it is disposed with or without treatment. So, we see this perpendicular lines like this. We have and what happens during rainy season, we have this overflows. So, that means during rainy season the sewage flows directly into the river. But during other seasons, what happens, the sewage does not go in this way, the sewage goes like this, and to do this we use different kind of weirs and all. It is called jumping weir, so that at certain level the water goes in this direction. When the water goes up, then the excess water jumps into another direction, or it just falls over. So, we will design those kind of sewer opportunities later on, but we use this kind of diversion, so that during the normal season, or when there is not too much rain, the water is collected, goes along this sewer line, which is called an interceptor sewer, which intercepts all the perpendicular sewers and then takes it to this particular point, where it could be released with treatment or without treatment. So, basically we can set up a STP over here and we can treat the storm water, but as you understand, during rainy season it is not possible to treat the storm water, too much amount of water. So, we just let it out directly, but in other seasons we can treat it in this particular way. So, the radial pattern, it is adopted when sewage is to be disposed on land around town. That means, we are disposing sewage in all directions. There may be a river, there may not be a river, or even if there is a river, we are disposing some part of the sewage in the river, some part of the sewage goes into the irrigation fields and all. Maybe the sewage is being used for sewage farming and so on. So, many outlets are provided and the sewers are laid radially outward from the center of the city, and many STPs are needed. However, suburbs can be served better, because what happens when we lay a sewer pipelines, then usually the pipelines, the city grows and then the suburbs come, and because the suburbs are far away, means from the central core area as well as probably the river, it would be far away, from the disposal point of the sewage it is far away. It is difficult to augment the network in those particular direction, the sewage network, because the sewage network is already laid for the other areas, then the city has grown. So, in that particular cases, if we have a radial pattern, that means we can grow in any direction, but the sewage network could be also expanded gradually in those particular directions, because we are releasing the water in that particular direction. So, the water when it is traveling in opposite direction, that means the pipeline has to be gradually become bigger and bigger. So, if already we have fixed the size of the pipeline, then it is not possible to make it even bigger. So, I think it could be illustrated better with the fan pattern. So, over here you can see that this is the outfall, this is the city, and this is the sewer network. The sewer is gradually comes in this direction, and then eventually it comes down to this particular point. So, definitely there are buildings all over the place. So, the pipelines at the end is thinner, and then gradually more sewage joins in. So, the pipelines become thicker and thicker and thicker. So, now if suddenly new growth has taken place over here, what will I do? So, I cannot expand the pipeline over in this direction. So, this is fan pattern. So, of course, in this pattern we cannot expand, but in the other pattern, that is the radial pattern, we could have expanded. That means, we could have expand the network over here, and from this side we can have another set of pipelines that is with the main pipelines, which would be disposing in the land over here itself. So, that is the benefit of a radial system, whereas in a fan system, as you can see, sewers are laid in such a way that the whole sewage flows to a common point where one treatment plant is located. So, fan pattern is definitely also we find in many cities where there is not too much option, but a single treatment plant, maybe financially only one treatment plant could be justified. So, in this particular case, this sort of a design is probably better. So, diameter of sewer line gradually increases, and but the overall cost is actually low, because we do not have so many kind of disposal points and so on. Then comes the zone pattern. So, the zone pattern is a modification of the interceptor pattern. So, everything else remains same. In zone pattern, instead of one interceptor, we have got multiple interceptor. So, in zone pattern, each zone is provided with one interceptor, and as you can see that this is one interceptor which takes care of this particular zone. This is the second interceptor which takes care of this particular zone. So, all the pipelines come to the interceptor over here, and similarly all pipelines come to this one, or it may also come from this direction, and then both the interceptor are connected with the pipeline, and then we have got one outfall. So, where we will use this kind of a system? This kind of a system is utilized where there is sloped areas. That means, we have got a mountainous area. So, there may be a settlement over here, then there could be settlement in this part of the slope. So, we can have one zone over here, another zone over here. So, we have one interceptor for this zone, another interceptor for this zone, and these are connected, and eventually it is taken out. So, this is how this zone pattern works. So, that actually takes care of the different types of system, but actually what I said is in Indian cities, we can conclude by saying is, in Indian cities we usually see a mix of different sewage collection system patterns. So, that is, there is no single pattern that is used. So, we see a mix of that, and we actually it is sometimes beneficial to have a mix of patterns. And the decision to go for a combined system or a separate system is not only technical, but depends on economic concerns and also the existing system in place. If the existing system is combined, then if we want to go for a separate system, then we have to consider a lot of other new things, right. So, sometimes we usually continue to use the same existing system or augment the existing system. So, these are some of the references you can use. Thank you.